So for problem number 5, we have a word problem. If a billiard ball is dropped from a height of 100 feet, its height, s, at time t is given by the position function s of t equals negative 16t squared plus 100, where s is measured in feet and t is measured in seconds. We want to find the average velocity over each of the following time intervals. So our first time interval is from 1 to 2, and because the velocity, average velocity, is just change in distance, which is, it's change in distance, which is s because it's in feet, over change in time. And by the way, this means change in. And to find the change in, we will do the final position minus the initial position. So the final position will be s of 2, and then the initial position will be s of 1, all over the change in time. So the final time is 2 seconds minus the initial time, which was 1 second. So now if we expand this equation, so s of 2 is equal to negative 16 times 2 squared plus 100 minus s of 1, which is negative 16 times 1 squared plus 100 all over 2 minus 1, which is just equal to 1. So after simplifying this fraction, so now that we have it all simplified, we end up getting negative 48. So we can look at the equation we used to get it, change in distance, which is in feet, over change in time, which is in seconds. And if we look at these units, that's feet over seconds, so feet per second. So we will put those units back in because it's a word problem and you want to keep your units. So negative 48 feet per second is our final answer. And now for our second interval, we are looking at the average velocity over 1 second to 1.1 seconds. So we're going to use that same equation that we had, change in s over change in t. So we have s of the final time minus s of the initial time all over the final time minus the initial time. And then we know from before that s of 1 is equal to 84, so now we just need to do s of 1.1, so that would be negative 16 times 1.1 squared minus 84 all over 1.1 minus 1, which is 0.1. Sorry about the noise. So we now, after simplifying this, can sorry, I forgot to add the 100 at the end from the original equation. We'll get negative 33.6 after putting that into our calculator. And if we remember from the earlier part of the problem, the units are feet per second. So that will be our final answer.